So let's go ahead into subnetting. We've talked about subnetting a little bit before, and subnetting can be tricky. So let's take a good look at it. Let's take a pretty long, in-depth look at it, and let's get a good idea for Network Plus what subnetting is and how we do it. So subnetting is adding additional networks to our standard A, B, and C private IP address ranges, or our A, B, and C public IP address ranges. So what does subnetting do for us? Well, subnetting allows us to take an IP address range, or take an IP address and say, okay, I have this particular IP address range, but I don't have enough, I have too many clients for this, potential clients for this IP address range. So for example, and don't take a too hard look at this area just yet, we'll take a look at that later. So let's say we have an IP address of, or we have an IP network of 192.168.0.x. So all of our IP addresses are on this IP address network. Well, that means we have, with our standard, so 192.168.0.x is a Class C IP address, because that fits in our range of addresses that are 192.168.0.0 through 192.168.255.255. So this is a Class C address. So the standard default subnet mask for this address range is 255.255.255.0. So this means that without subnetting, using standard usage, we have a potential of 254 hosts. So we don't include our broadcast, we don't include our 255 because that's broadcast. So that means we can use 254 potential hosts. We can have 254 potential computers in this network. Now if we're a large enterprise, this may be a good number for us, or this may be even too few, and we may need to use a different class of IP address range. But if we're a small office, we're probably not going to have 254 computers on the same IP address range. It's just not going to happen, especially if we're a small home. We may not have 254 computers on that same IP address. So we want to be able to take this and we want to break it up into smaller subnets without necessarily going and changing our actual IP address here. Now we could change to a different network simply by changing one of our octets and changing this to 192.168.1. Whatever. That's a completely valid way of changing to a different, completely new network. But say for whatever reason, maybe departmental issues, or maybe our IT department assigned us this, we are stuck to addresses that begin with 192.168.0. So we want to break this up. We want to subnet it. We want to take this, and instead of having one network that we can use, we want to have multiple networks, with sacrificing a little bit of the number of clients that we can have in each network, a number of computers that we can have in each network. All of our subnets have to have a beginning and an end number that we can't use. The first number is going to be our network ID. It's going to be the ID that identifies our network. We can't use that for a client. A client computer, a computer cannot be assigned the IP address of the network ID. The network ID just starts off our subnet and lets us know, okay, this is our first address, this is our network ID address, and all of these addresses until the end of my segment are going to be this particular subnet. They're going to be the 192.168.2 subnet, or the 192.168.0 subnet. So our first address is our network ID. It cannot be used. It cannot be assigned to a router or a switch or a computer or an iPad or a laptop, anything. It's our network ID. And this is always going to be an even IP address. So it's going to end with an even number. So we're not talking about the including the host ID. We're talking about when we take our network portion of our IP address, our network ID is going to be even. So it's going to be something like 192.168.1.0. We consider that an even number. Or 192.168.1.16, because that last number is even there. So our network ID is going to be our even number. Now our last number is going to, in our subnet, is going to be what our broadcast ID is, or our broadcast IP address is for that subnet. All of our networks have to have a broadcast IP address. There has to be some way that a computer, if it needs to send a message out broadcast to anyone that will listen, can have an IP address that it sends to. Now, a single computer, a single host, or a single switch or router can't be assigned a broadcast IP address, because how will it differentiate between packets that are just being sent to it or packets that are being sent to everybody? So we can't use this last address, this broadcast address, which is always going to be odd. So in our subnet range, there are going to be two addresses that we can't use: our first and our last address, our network ID, which is our first address and always even, and our broadcast ID, which is our last address in our subnet and always odd. So let's move on. Now, how do we identify what increment we use, or where we start our subnets? Well, it's pretty simple. So we have our IP address with our subnet mask. Now, this is speaking in a situation where we took a computer already that has an IP address and is in a subnet, and we're trying to identify which subnet it's in. So we were given an IP address and with a subnet mask, and we're going to find N. Well, what is N? N is the number, or it's the number in our subnet that's the farthest left subnet number, which is not 255. So if we look in this example, N will be 240, because it's our farthest left, which is unfortunately the first one on our right. But if we had, this won't work with this class, but if we had 240.0, it would be this same number, but it would be 1 over. So it would be our farthest left. We'll have to redo this because that wouldn't be the right for that class, 255.240. So it would be 240 there. We take N and we subtract it from 256. Now, why do we use the number 256? Well, if we talked about earlier that when we break it down when we break down our individual octets, each individual octet potentially has 256 different values, because you have 1 through 255 and 0, because 0 is still a value. So 0 can be a network ID, so we consider it a value. So we have 0 to 255, and that's 256 complete values. And you subtract N from it, and you get the network increment. Now the network increment, with the network increment, it's what we're using to increment up our assigned IP address range and be able to find where our different subnets are. So let's explain a little bit. So if we say, in this example, we have 240, we subtract it from N, and we get our 16, or we get our 16, then our network increment 16 is we're going to increment up by 16. So 16, 32, on and on and on, up our entire range, which goes all the way up to our 255. Now our last usable address, now how do we find our network ID and our broadcast ID? Well, our network ID is going to be that first address that we hit in our network increment. So 0, 16 are all going to be our network IDs. Our broadcast ID will be the last address, and remember, it will be odd. So 16 and 32, if there are network IDs, then 15 and 31 would be our broadcast ID, because if we have 0, 16, 32, then the address, these are our network IDs, then the address right before our network ID is the previous subnet's broadcast ID. 15, 31 would be this subnet's broadcast ID, this subnet's broadcast ID. So we'll take a look at this a little bit more in depth when we actually break everything down. A little harder to explain without actually going through our example here. But that's going to be the beginning of how, if we take an address, we see that it's been subnetted, we find which network increment it's in, other addresses that we can talk to, and what its network ID and its broadcast ID are by using this, the value of n, 256 minus n, to get our network increment, and then going up and finding out which network subnet that it's in. We're going to talk about after the in the same segment, but after the little break that we'll have, and we'll actually discuss taking the binary and being able to find out how many subnets and how many hosts a particular subnet can have. But that's going to be a bit that we're going to dive more in depth with that. But right now we're just going to stick with the little bit of basics right now. We're not going to break out the binary just yet. We changed our subnet here. This IP address, 192.168.1.37, is an IP address of a computer on our network. We've subnetted out this network, we can tell, because this is a non-standard subnet mask for this address. This IP address is a Class C IP address, as we can tell by, we know what our Class A, B, and C address ranges are. And as such, a Class C address range has a standard IP address of has a standard subnet mask of 255.255.255.0. This subnet mask, on the other hand, is 255.255.255.240. So what does that mean for this IP address? Which subnet is it in? How do we identify which of the potential networks that it's in? Well, our first step again is to identify n. N is going to be our first subnet mask address, our first subnet mask octet over which does not have 255 in it, so it's 240. So n is going to be 240. Now, in order to find our network increment, which unfortunately I didn't write up here, in order to find our network increment, we need to subtract 240 from 256. So our net increment is going to be 256 minus n. So 256 minus 240 equals 16. So 16 is our network increment. So now how do we find the network ID of this IP address? This IP address is in a subnet. So how do we find out which one? Well, we go up and we increment by 16s. So our first network we're going to have is going to be 16 to 16 and then 32. So first network 16, next network ID 32, next network ID will be 48. So this fits in between 32 and 48. So that means that its net ID that it's in is going to be 32. So net ID of 32, how do we find out its broadcast ID? Well, the next network ID, the next subnet section, is going to be starting with 48. So that means its broadcast segment will be one less than that. It'll be 47. That means that for the subnet that this IP address is in, its net ID is 32, its broadcast ID is 47, and that leaves us with usable addresses of 33 through 46, because our addresses can't be our network ID and our address can't be our broadcast ID, so our usable addresses are going to be 33 through 46. So that fits right in there. So if we see any other computers that have an IP address of 192.168.1.33 through 46, those are computers that are on the same subnet of this address. If we see any IP addresses that have an address of 48, 49, or 2 or 3, those are subnets that this address is actually going to have to go through a router in order to talk to. because we can't talk to those addresses. They aren't on our same network. If we send out a broadcast message, those devices aren't going to get it. So we've successfully subnetted, or we've successfully identified which subnet this particular IP address is in by using our in rule and finding our network increment, which was 16. We incremented up 16, 32, 48. So it's in between our 32 and 48. Our network ID is 32. Our broadcast ID is the next network ID minus 1. So broadcast ID is 47. And our usable addresses are 33 through 46. Now, how do we find the actual number of usable addresses, the usable hosts in our network ID? Well, in order to find the number of usable hosts, we can just take our network ID and subtract 2. So in this range of usable addresses, we have 14 hosts that can be on this subnet. And the way we come up with that number is our network increment minus the network ID and the broadcast ID, because we can't use those. So our usable host addresses, 33 through 47, 14 total addresses, counting 33 and counting 46. And so we just take our network increment 16 minus 2 for the net ID and the broadcast ID equals 14 usable addresses in that subnet. This is going to be our introduction, a little bit of an introduction to subnetting. We now know that subnets allow us to add additional networks to a standard class A, B, or C IP address. We essentially are changing our subnet mask from our standard subnet mask for that class. We're adding on additional numbers to our subnet mask, whereas a standard class C address, this is a standard class C address, would have a standard subnet mask of 255.255.255.0. We see that this subnet mask is different, so we know that it must be subnetted. So in order to find out which subnet that this address is in, which other devices it can talk to, and what its network ID and its broadcast ID is, we run our little algorithm here, where we find our first number in our subnet mask, which is not 255 and which is the most to the left, which is 240. We subtract 256 minus 240 to find our network increment. We increment our networks up 16, 32, 48, and we determine that our IP address .37 is between 32 and 48. We find our network ID and our broadcast ID, and we find our other usable addresses for that subnet. So that's our small introduction there. Now let's move on, and now we're going to get down and dirty with actual IP addresses and translating them into their binary, and using that binary to find out how subnets work, how the binary affects the subnet masks, and how it determines how many subnets we can have and how many hosts that we can have once we subnet out a network.